In this lesson, we will discuss integration by the method of substitution. We use an appropriate substitution to bring the form of integral to a form that we are familiar with. Now, what are some of the basic integral forms that we already know? Well, we know that integral of du, here I am using u as a variable, integral dx equal to x plus c, integral du is u plus c. Similarly, integral a du, what is integral a du? A is a constant, that will be au plus c. How about integral u to the power of n du? That is the power rule, which is u to the power of n plus 1 over n plus 1. These are the basic integration rules that we already know. We also know how to integrate some basic trig functions. In other words, you know that integral sine u du, integral sine x dx is negative cos x plus c. Integral sine u du will be negative cos u plus c. Integral cos u du is sine u plus c. Can you remember at least one more of the trigonometric functions that we talked about that can be integrated? Well, we can integrate secant squared u with respect to u. Integral secant squared u is, well, tan u plus c, because the derivative of tan u with respect to u is secant squared u. Well, these are some of the basic integration formulae that we know. That's all we know. Now, if you get an integral in any other form, we've got to reduce it to one of these simple forms that we know by using a proper substitution. And that is what we will be discussing in this lesson. Alright, let's see how we can integrate this. Integral 1 plus 2x raised to the power of 4. Now, you know the basic form. The basic form that you know is integral u to the power of 4 du is u to the power of n plus 1 over n plus 1 plus c. Now, is it possible to bring this to the form integral u to the power of n du by an appropriate substitution? Yes, we can do that by calling this quantity, look at that, call the quantity inside equal to u. So let's do that. Let's take this quantity and say 1 plus 2x equal to u. Now there's a problem here. That is, when you replace this quantity as u, the integral is going to read integral u to the power of 4 dx. But can you integrate u to the power of 4 with respect to x? No, you can only integrate u to the power of 4 with respect to u. You can integrate t to the power of 4 with respect to t. You can integrate x to the power of 4 with respect to x. You cannot integrate u to the power of 4 with respect to x. And that means when you replace this 1 plus 2x equal to u, you need to replace this dx in terms of u. The dx needs to become du. Now, how are we going to do that? Well, we know, I'm sure you know the concept of differentials. Don't you remember that? Is it possible to find the differential of each term in here? All right, help me find the differential of each of these terms. What is the differential of 1? Well, the derivative of 1 is 0. The differential of 1 is 0. So what we do is we find the differential of the left-hand side and the right-hand side. So find the differential of each term. The differential of 1 is 0 plus. What is the differential of 2x? What is the differential of x? Differential of x is dx. The differential of 2x is 2 dx. All right, tell me, what is the differential of x squared? The differential of x squared is 2x dx. Is that right? Yes. What is the differential of sine x? The differential of sine x is cos x dx. I want you to recall all these skills that we practiced earlier. All right? So what are we doing here? We are finding the differential of each term. The differential of 2x is 2 dx equal to, what is the differential of u? The differential of u is du. Now look at that. We used the substitution. This is the substitution we did. We found the differential of each term, and that is going to give us a relation between dx and du, which will help us to replace this dx. So what we're going to do is solve for dx from there. What is dx equal to? This is 0. 2 dx equal to du gives me dx equal to du divided by 2. Now, what that means is we will now be able to take, remember dx equal to du over 2. We will be able to take this du over 2 and replace that dx. So, our 1 plus 2x will become u, and this dx will now become du divided by 2. So, what does our integral now become? We can now write this integral as equal to integral, this quantity is now u to the power of 4, and our dx is now du divided by 2. Now this 2 is a constant. We bring it out. How does it come out? 2 is on the denominator, so it will be 1/2 integral u to the power of 4 du. Well, this is the form that we know now. What is integral u to the power of 4 du? The power rule. So that will be 1/2 times integral u to the power of 4 du is u to the power of 5 over 5. So that will be u to the power of 5 over 5. And that can be written as, the denominator now contains 2 times 5, that is 10. So that will be u to the power of 5 over 10. But we want to integrate this quantity. Our answer should not be in terms of u. So what all we now need to do is bring back our u. Our u is 1 plus 2x. So replace our u, that will be 1 plus 2x to the power of 5 over 10 plus our constant of integration. In fact, in every term that we write, there will be that constant of integration. I have actually left out that. There will be a c there, there will be a c there, and so on. So our final result is integral 1 plus 2x, the quantity to the power of 4 dx, is 1 plus 2x to the quantity raised to the power of 5 divided by 10 plus c, and that's our result. Okay, That's a simple method, is that right? So, when you have a quantity like this, reduce it to the form that we already know by an appropriate substitution. And the method requires that your dx needs to be replaced in terms of the substitution as well. Okay, let's look at another one. Integral t cube square root quantity t to the power of 4 plus 2 dt. The variable here is t. We need to integrate with respect to t. Well, this is a complex quantity. Now remember, if you have something like this, integral square root t dt, we can do this. How? By writing square root t as t to the power of 1/2. You can then use the power rule. But we don't know how to integrate a complex quantity like this. So our aim is to reduce it to the form that we know. So tell me, what is the substitution we will use? Which quantity are we going to call equal to u? Well, the best candidate seems to be the quantity inside the square root. So we take the quantity inside the square root and call it equal to u. So let's do that. Always do it on the side like this. Let t to the power of 4, let t to the power of 4 plus 2 equal to u. But the moment you do that, you cannot move away from there until you finish the business. What is the business that needs to be finished? If this quantity is called u, you cannot have any other t in there. All of them need to be replaced in terms of u. So to begin with, we find the differential of each term. I'm going to repeat that several times. We find the differential of each term. This is what you need to do every time you do a substitution. The moment you do a substitution, find the differential of each term. Why? Because using the substitution, we need to replace the remaining terms in terms of that substitution. All right, tell me, what is the differential of t to the power of 4? Well, the differential of t to the power of 4 is 4t cubed dt. Plus, the differential of 2 is 0, will be equal to the differential of u is u. Well, now look at what we have here. Now, this quantity t to the power of 2 plus 2 is going to be called u. So this is going to be u. What are the remaining terms? The remaining terms are t cubed times dt. T cubed dt. Now look at this here. There's a t cubed dt here. So what we need to do is solve for that quantity. Therefore, what is t cubed dt equal to? T cubed dt is, if this is 0, it will be du divided by 4. That means when t to the power of 4 plus 2 is replaced by u, this t cubed times dt will be replaced by du over 4. And so, what does the integral now become? Let's put it all together. It will be integral, first we write this, square root of what? Square root of this quantity is u, square root of u, and what is left there is t cubed dt, and t cubed dt is du divided by 4. Now look how simple it became. Now as we did before, we're going to do two things here. One, The 4 on the denominator is come out to become 1/4. So you got a 1/4 coming out. And square root u is going to be written as u to the power of 1/2 du. So that we can use the power rule. And now we can integrate. That will be 1/4 of, what is integral of u to the power of 1/2? It will be u to the power of 1/2 plus 1. What is 1/2 plus 1? It's 3/2. U to the power of 3/2 divided by 3/2. The 2 will go up. Let me write that 1/4 in its proper form. It'll be 1/4 times u to the power of 3/2 divided by 3 divided by 2. The 2 goes up. Plus c. And now you have the 2 goes with the 4, leaving 2. 2 times 3 is 6. Is that right? And you have u to the power of 3/2 over 6 plus c. But that is not the final result. Our final result comes only when you replace your u with this. So our answer will be, therefore, t to the power of 4 plus 2 raised to the power of 3/2 divided by 6 plus c. That's right. Or you can write it as 1/6 t to the power of 4 plus 2 raised to the power of 3/2 plus c, and that's the result of the integration. Now let's discuss a bit about the last problem we did. The last problem we did is this: integral t cube square root t to the power of 4 plus 2 dt. Now, is it possible to do something like this? Integral t squared square root of t to the power of 4 plus 2 dt. While this can be done with an appropriate substitution. What is the substitution we used? T to the power of 4 plus 2 equal to u. And we found the differential. The differential gave us 3t cube dt equal to du. In other words, not 3, it'll be 4, is that right? 4t cubed. In other words, we are able to replace t cubed dt in terms of du. Now, is it possible to do this integration? No, why not? Because when you substitute t to the power of 4 plus 2 equal to u, the differential of that will not yield a t squared. So, when you have t to the power of 4 plus 2 inside the square root, you need a t cube outside in order that it is a differentiable form. In other words, integral x cube square root of x to the power of 4, it doesn't matter what value that constant is. This can be integrated. Similarly, I'm going to write another one. Now, integral, let me write the square root first. Integral square root x to the power of 6 plus 8 dx. Now, can you integrate this? No. But if there is an x to the power of what outside? Now remember, the derivative of x to the power of 6 contains x to the power of 5. That the differential of x to the power of 6 is 6x to the power of 5 dx. So if there is an x to the power of 5 outside, then this can be integrated. You must be able to look like this when you do your substitution. Now, this can be done by a substitution because the differential of t to the power of 4 contains t cubed. This cannot be done because the differential of t to the power of 4 does not contain a t squared. So whereas this can be integrated, this cannot be integrated easily. So there are forms that can be easily integrated. There are forms that you cannot easily integrate it. All right, look at this problem. Solve the differential equation dy by dx equal to x minus 4 over square root x squared minus 8x plus 1. What is a differential equation? A differential equation is an equation that contains the derivative of a dependent variable. Now here, y is the dependent variable, x is the independent variable. We have the derivative of the dependent variable with respect to the independent variable, dy by dx. And so this becomes a differential equation because it contains the derivative of the dependent variable with respect to the independent variable. What is the meaning of solve? Solve for what? When you are asked to solve a differential equation, always it means solve for the dependent variable. Solve for y. Now, if you know dy, how do you solve for y? Well, you know that integrating dy will give you y. And so, in order to solve the differential equation, we need to write this in such a way that dy alone will be on the left and everything else will be on the right. How do you do that? All we need to do is multiply both sides by dx. All right, let's do that. Multiply left-hand side and right-hand side by dx. That will give me, what does that give me? That will give dy equal to x minus 4 divided by square root x squared minus 8x plus 1 times dx. Multiply both sides by dx. Now, we are looking for y, and y can be obtained by integrating the left-hand side. Well, when you integrate the left-hand side, you integrate the right-hand side also. So what we do is integrate both sides. So we integrate both sides. What does that give you? That will give you integral of dy equal to integral x minus 4 over square root x squared minus 8x plus 1 dx. Well, integrating dy will give you y, and that means in order to get the form of y, we must be able to integrate the right-hand side. And to integrate the right-hand side, you must make a substitution. Well, I want you to stop the video now and look at this and say, what substitution can we make here so that using the substitution, we should be able to replace the remaining quantity? Now, well, I have already answered the question for you. I am assuming that our substitution, you see, most of the time, it will be the quantity inside the square root sign. So we will take the quantity inside, x squared minus 8x plus 1 equal to u. And then find the differential of each term and use that to see if you can replace x minus 4 dx in terms of u, the substitution. Okay, I'm going to take this off and start with this on the top. So we have now this integral dy equal to integral of the right-hand side. And you know integral dy, the left side will be y. So we will be able to say y equal to. Well, that's going to stay there for a while. We need to integrate this. What is the substitution that we're going to make? Well, as I said, it's always easy to figure that out. Take the quantity inside the square root, and that will be x squared minus 8x plus 1, and we call it equal to u. And once you call this quantity equal to u, we need to replace everything else in terms of u. And the best way to look for is find the differential of our substitution. Let's find the differential of each term. The differential of x squared is 2x dx minus the differential of 8x is 8 dx. The differential of 1 is 0, so we don't have to worry about it, equal to differential of u is du. Well, when you do this, you keep an eye on here, because we need to replace x minus 4 dx in terms of u. Now, is it possible to produce x minus 4 dx from this quantity? Well, yes. But all we need to do is factor out the common factors. What's the common factor there? 2 dx is common. So we take out 2 dx. That will be 2 dx times x minus 4 equal to du. Now look at this. This is the quantity that we have here. X minus 4 times dx. So solve for that. Therefore, x minus 4 dx equal to du divided by 2. You see, that's going to make it a lot simpler. That means when you replace this quantity as u, this quantity x minus 4 dx becomes du over 4. And what is our integral now become? Our integral now become 1 over square root u, isn't it? 1 over square root u, and this quantity is now du over 2. That's right. Now, that will be, the 2 on the denominator will come out as usual. That will be 1/2 integral. We have 1 over square root u. Well, that will be u to the power of negative 1/2, isn't it? Square root u is u to the power of 1/2. 1 over u to the power of 1/2 is u to the power of negative 1/2 du. And that will be 1/2 times, can you integrate that for me? U to the power of negative 1/2 du integrated will be u to the power of negative 1/2 plus 1 divided by 1/2 plus 1. I want you to keep that in your mind and work it out in your mind. I'm not writing that there. The integral of this will be u to the power of negative 1/2 plus 1 divided by negative 1/2 plus 1. What is negative 1/2 plus 1? Negative 1/2 plus 1 is 1/2. So this will be u to the power of 1/2 divided by 1/2. That'll be 1 divided by 2. 1 and the 2 will go up. And you notice that here the 2's will cancel. And of course there is a c there. And that will be u to the power of 1/2 plus c. And since the original expression is a square root expression, we can bring that form back. U to the power of 1/2 is square root of u plus c. And finally, we need to replace our u. What was our u? Our u is the quantity. So our answer is y equal to square root of x squared minus 8x plus 1 plus c. And this is the solution of that differential equation. The solution is we solved for the dependent variable y. All right. How about this? Integral x sine x squared dx. Well, you know how to integrate this. Integral of sine u du. What's integral of sine u du? It's negative cos u plus c. Well, is it possible to bring it down to that form? We don't know how to integrate sine of x squared. We know how to integrate sine x, but we don't know how to integrate sine of x squared. It needs to be brought to a form that we are familiar with. So what do? Well, we do a substitution. What substitution? We need to call x squared equal to u. What is the first thing to do after you make a substitution? Find the differential of each term. What is the differential of x squared? The differential of x squared is 2x dx. I hope you are thorough with these concepts now. The differential of 2x, x squared is 2x dx. Differential of u is du. Now what that tells you is that once the x squared has been replaced by u, the remaining we need to replace is this x times dx. That's right. That x times dx can be replaced from here. What is x dx equal to? X dx is du divided by 2. And therefore, by doing our substitution, this integral now becomes what? This can be now written as integral sine x squared becomes sine of u, sine u, and x times dx becomes du over 2. So this will be sine u times du over 2. And what does that give you? As usual, the 2 on the denominator will come out as 1/2. That'll be 1/2 times integral sine u du. And that you know how to integrate. That will be 1/2 times integral of sine u du is negative cos u plus c. And you can do 2 things in the next step. The whole answer is negative, and u can be replaced by x squared. So the answer is negative 1/2 cos of x squared plus c is the answer. That's right. Okay, now tell me. If I take away a couple of these steps, I'm going to ask you a question. What we did now here is integrate x sine x squared dx. Now, is it possible to integrate, say, this? Integral x squared sine x squared dx. Can you do this? Well, no. Why not? Because by doing a substitution x squared equal to u, the differential only gives you x dx. The differential does not yield x squared dx. Therefore, you cannot do this. Now tell me, if I have to integrate, say, sine of x to the power 4 dx, what else must come along with this so that this is an integrable form? To make it in a form that can be integrated, there must be something else with this. What must be that something? That something must be x cubed. Why? Because when we replace our x to the power of 4 equal to u, the differential of this will yield x cubed dx. So x cubed dx can be replaced. Whereas x squared dx cannot be replaced from this substitution. So when you look at an integral, you can judge, can it be integrated, or is it a form that you cannot integrate? Okay, so you must understand these basic principles that we've been using. All right, let's look at another one. Integral cos of 6x dx. Well, you know how to integrate cos x. You know that integral cos x dx is sine x plus c. But how about integral cos of 6x? Well, you need to bring it to a form you can do integral cos u du as sine u plus c. So what you need to do is take this 6x and call it equal to u. So we say 6x equal to u. And what is the next step after doing this substitution? Find the differential of both sides. What is the differential of 6x? The differential of 6x is 6 dx, and the differential of u is du. Now, once you replace your 6x as u, this dx needs to be replaced as well. That means you need to solve for dx from here. Dx equal to du divided by 6, not 4. Alright, so we have our 6x replaced by u and dx replaced by du over 6. Our integral now becomes integral cos of u times du over 6. Well, first of all, we remove that 6 from the denominator and take it out. That will be 1 over 6 integral cos u du. And what is integral of cos u du? Is sine of u. So that will be 1/6 sine u plus c. Or we will now replace our u by 6x, and our final answer is sine of 6x over x plus c. I want you to see the pattern there. Integral of cos of 6x dx is sine of 6x divided by 6 plus c. Now, let me just take off this and ask you a question. What is the derivative of sine 6x? What is the derivative of sine 6x? Now remember, if you go back and look at the chain rule we did, the derivative of sine 6x is cos of 6x times the derivative of 6x, which is 6. So the derivative of sine 6x is 6 cos 6x. Alright, what is integral of sine 6x? By using this pattern, if you look at this, integral of cos 6x dx is sine 6x divided by 6. So integral of sine 6x will be negative cos 6x divided by 6. Is that right? That's right. Integral of cos 6x is sine 6x divided by 6. Integral of sine 6x will be negative cos 6x divided by 6. In other words, in general, I'm going to write down some of those fundamental integrals that we already know in terms of this. Now, give me a second. Let's start with this. What is integral of sine mx dx. Integral of sine mx dx. It will be negative cos mx over m plus c. Similarly, integral of cos mx dx will be sine mx over m plus c. How about this? Integral secant squared mx dx will be, well, integral of secant squared x is tan x. Integral of secant squared mx dx will be tan of mx over m plus c. So, very easy to confuse for beginners. So, remember, when you find the derivative of a function like this, the coefficient of x will get multiplied. But when you find the integral, the coefficient will get divided. In other words, one more time, let me say d by dx of sine mx. In other words, the derivative of sine mx with respect to x will be m cos mx. When you find the derivative of a sine function like this m will get multiplied. But when you find the integral, that m will get divided. Why? Because these processes are opposite of each other. In other words, if you find the derivative of this, you will get this, don't you? Well, let me take this away and ask you to do that. On the right hand side, we got negative cos mx over m plus c. And I just said, if you find the derivative of the right side, you must get this. All right. Tell me, what is the derivative of cos mx? The derivative of cos mx is negative m sine mx. And, well, this is just the derivative of cos mx. And there is a negative there already, and there is an m down here. And of course the derivative of c is 0. And look at the way the negative goes, m and m cancels, you get our sine mx back. The derivative of this quantity is sine mx. Okay, so those are things you must write down and learn, some of those basic integration rules. All right, try this one. Integral 2x minus 1 over square root quantity x plus 3 dx. Well, what kind of substitution will reduce it to a form that we are familiar with? When you have a square root quantity in the denominator, you must, well, say, well, it is that quantity I'm going to call u, x plus 3. So let's try that. Let's say x plus 3 equal to u. Let's do it over here. X plus 3 equal to u. And remember, every time you do a substitution, always take the differential of each term so that we can replace the remaining terms in terms of the substitution. The differential of x is dx. The differential of 3 is 0. And the differential of u is du. Well, that gives you dx equal to du. What's the problem here? The problem is we have replaced x plus 3 equal to u, and the dx can be replaced as du. But we have still a 2x minus 1 left. What do we do with that x? Well, It's very simple. If x plus 3 equal to u, is it possible to replace this x in terms of u from there? Yes. So don't give up. We got to keep, you got to persist and keep following the method. So we say, I have replaced x plus 3 by u. I can replace dx by du. That means I need to now replace this x. All right, go back to the substitution and solve for x from there. If x plus 3 equal to u, then x equal to u minus 3. So what we need to do is this x needs to be replaced by u minus 3. Our dx will be du and x plus 3 will be u. We've got everything taken care of. Let's bring it all and write down that integral. How does that become now? The integral now becomes integral 2x minus 1 becomes 2 times u minus 3. X is replaced by u minus 3 minus 1 over square root of x plus 3 is our u, so that would be x plus 3. Oops, our x plus 3 is our u, so square root of u times dx is du. You can see now everything is reduced to our substitution. Well, what we now need to do is try and simplify this. All right, this will be equal to integral. Let's first of all distribute this. This will be 2u minus 6 minus 1 over square root u du. Okay, that will be integral 2u minus 7 over square root u. I'm going to write square root u as u to the power of 1/2 du. Now, once we have reached here, you should be able to do this. How? How are we going to integrate this now? We need to split this into 2 terms so that each term will be a power. We can use the power rule. So it'll be 2u divided by u to the power of 1/2 minus 7 divided by u to the power of 1/2. That's the method in here. Very often I know students get stuck in here. What we need to do is, because the numerator contains 2 terms, we can split that into 2 terms. So that will be, watch here, that will be integral. Our first term will be 2u divided by u to the power of 1/2 minus 7 divided by u to the power of 1/2 du. Well, help me write the next step. I want you to look at this. Now here, 2 is a constant. What is u divided by u to the power of 1/2? U divided by, well, u can be written as u to the power of 1/2 times u to the power of 1/2, isn't it? So u divided by u to the power of 1/2 is u to the power of 1/2. So that will be integral 2u to the power of 1/2, that is this term, minus, what is 7 divided by u to the power of 1/2? Bring the u to the power of 1/2 to the numerator. That will be 7 u to the power of negative 1/2 du. Okay, now, once we reach this, it becomes now simple. So what I'm going to do is, I'm going to take this and start from the top. Okay. Now, this is where we are integral 2u to the power of 1/2 minus 7u to the power of negative 1/2 du. We can now integrate each of these terms. Is that right? Now tell me, how do you integrate 2u to the power of 1/2? 2 is a constant, so it will remain. Integral of u to the power of 1/2, use the power rule, is u to the power of 1/2 plus 1 over 1/2 plus 1, which is u to the power of 3 over 2 over 3 over 2. Look at the way I'm going to write it. That 2, the denominator will go to the numerator and multiply. So u to the power of 3 over 2 over 3 divided by 2 will go to the numerator and multiply, minus, okay, 7. What's the integral of u to the power of negative 1/2? It will be u to the power of, look, I'm going to write it here, u to the power of negative 1/2 plus 1 over negative 1/2 plus 1. That is integral of this. Negative 1/2 plus 1 is 1/2. So this is simply u to the power of 1/2 divided by 1/2. So it will be 7 times u to the power of 1/2 divided by 1/2. 1 divided by 2, the 2 goes up. Okay, plus c. And that's equal to, now, is there anything that we can factor out? Now, discount that c, we will simplify this, that c will remain there. Is there anything we can factor out in here to simplify? If you notice, u to the power of 3 over 2 is u times u to the power of 1/2. So u to the power of 1/2 is common, a 2 is common. So, and I'm also going to take out a 3 on the denominator. Now remember, when I take out a 3 on the denominator, look at this, I'm going to introduce a 3 on the denominator, well, by multiplying the numerator and denominator by 3. That makes no difference, is that right? So that means I can take 2/3 common from both terms and u to the power of 1/2 common. So I'm going to say 2 over 3 u to the power of 1/2 comes out. What is left here? 2/3 has come out. What is left here is, look at that, u to the power of 3/2 came out. What is left is a u. So that is 2u is left there, minus what is left here. 2/3 have come out, leaving a 21 there, and u to the power of 1/2 has come out. So it will be simply minus 21 plus c. I hope you understood the simplified version there. What I did is, I took out a u to the power of 1/2, and I took out a 2/3, leaving a 2u there, because u to the power of 1/2 times u is u to the power of 3/2, minus, leaving a 7 times 3, 21 there. Now, that will be, we can now replace our u. What is our u? Our u is x plus 3. So that will be 2/3 of x plus 3 to the power of 1/2 times 2 times x plus 3 minus 2 plus c. Okay, one more thing. First of all, we need to distribute inside here and simplify. Can you do that? 2x plus 6 minus 2. It will be 2x plus 4, is that right? That's right. And that will be 2/3 x plus 3 to the power of 1/2. Our original expression contained square root, which means we should now convert that power 1/2 to square root. That'll be 2/3 square root x plus 3 times, simplify this for me, if you do it like this, 2x plus 6 minus 2, it'll be 2x plus 4, 2x plus 4 plus c. And maybe one more thing you can do there. What is that one more thing, a very simple thing left there? If you notice 2x plus 4, there's a 2 common there. And that 2 will come out, multiply with this 2, giving you a 4/3. What will be left there? X plus 2. So that will be 4/3 square root x plus 3 times x plus 2 plus c, and that is the final result. Always try and simplify it as much as possible. Alright? Now it is common that I make small mistakes in these kind of simplifications. Now if you can spot those mistakes and let me know, you can earn 1 extra points each time. Now what is the simple mistake I made in here? The simple mistake I made in here is read this 21 as 2 and factored out a 2 there. In other words, here when I brought back this 21, I wrote 2. So if you noticed, I'm going to apply that correction there. This is minus 21 and not minus 2. That means the simplification I did here will remain, if you notice, 2x plus 6 minus 21. And that will be 2x plus 6 minus 21 will remain 2x minus 15. So this will be 2x minus 15 plus c, and this will not be like that because this will not become 4, it will remain 2, and this will remain what? That will remain 2x minus 15. So look for these simple errors. Now detecting an error is a good skill in learning mathematics. So when you watch these videos, always look for these small errors. Very often I point something and read something else, or I say something and write slightly different things. So keep watch on all those small things. Alright, try this one now. The production and sale of Japanese cars in America varies from month to month according to demand. A model is n equal to 4,825 plus 210 cos of, look at the quantity, this is the argument of the function, cos of pi times t minus 2 over 6, where t is the time in months, with t equal 1 corresponding to January. Find the average production level given by the model during the first quarter, that is, from t equal to 0 to t equal to 3. In other words, we need to find the average value of this function. Now, can you recall the expression for average value of a function we discussed in the maybe a couple of lessons ago? Average value of a function on an interval AB is 1 over b minus a integral a to b of f of x dx. Now here the function is a function of time. Now another thing that we need to understand, and you need to understand and use, is how do you integrate, if you have to integrate here, cosine of this quantity. Now you must understand, if integral of cos t is sine t, the integral of cos of t minus 2 will be sine of t minus 2. There will be no change there. But this t minus 2 is multiplied by pi by 6. We just did about a few minutes ago that integral cos mx is sine mx divided by m. So here, integral of cos pi by 6 times t over 2 will be sine of pi by 6 times t over 2 divided by this pi by 6. Very important. Integral cos mx is sine mx divided by m. Here, pi by 6 is your m and t minus 2 is your x. All right, let's get going. Now, that will give you what will be your steps in here. We are looking for the average value of n on the interval 0 to 3, and therefore we will use the average value function. Average value of a function is 1 over b minus a, 3 minus 0, integral 0 to 3 of our function with respect to t. Now, that means we need to now integrate each of these terms. Now, I just gave you this. Integral of cos at dt is sine of at divided by a. And therefore, integral of cos, this is a, t minus 2 dt will be cos sine of this quantity divided by. So here, that will be 1/3. What is integral of 4825 dt? You must read each term. Remember, dt is common for all the terms. Integral 4825 dt is 4825 t, plus 2010 is a constant. Integral of cos of this quantity, pi by 6 times t minus 2, is sine of pi by 6 times t minus 2 over pi by 6. And that goes from lower limit 0 to the upper limit 3. Alright? To find the value of this, what do? First replace t equal to 3, is that right? That is the upper limit value, minus replace t equal to 0. Let's do that. When you do, I have actually replaced there. I have replaced t by 3 here. So t is replaced by 3. These are the two places we had t. I've replaced that with 3. Minus the lower limit, replace t by 0. Now, what does that give you? That will be 4825 times 3 is this. As I told you, very often I make small mistakes, and it is your job to locate and tell me where such mistakes are made. Alright? That will be, let's first do the upper part. It'll be 1/3, this number, plus 210. Now look at this. 3 minus 2 there is 1. So that will be sine of pi by 6 divided by pi by 6. Is that right? Sine of pi by 6 divided by pi by 6. That is the upper limit. Now minus this quantity. This is 0. Now, this is 0 minus 2. That will be negative 2. So that will be negative 1/3, 210 sine of, look at that, negative 2 times pi by 6. That will be negative 2 pi by 6. I hope you understand this. This will become negative 2. Negative 2 times pi by 6 is negative 2 pi by 6 divided by pi by 6. Alright, we will now look for these values. What is sine of pi by 6? Always keep that unit circle with you. Sine of pi by 6 is sine of 30 degrees, that is 1/2. And what is sine of negative 2 pi by 6? Well, you should be able to do that. All right, so this will be 14,475 plus 210 times sine of pi by 6 is 1/2 divided by pi by 6 minus 1/3 times 0 minus. Now, sine of negative 2 pi by 6 is the same as sine of pi by 3. How? How is that possible? Now, recall that sine of negative x is negative sine x. Is that right? You must know those simple identities. Sine of negative theta is negative sine theta. So here, sine of negative 2 pi by 6. 2 pi by 6 is pi by 3. So sine of negative pi by 3 is negative sine pi by 3. So that positive sign now becomes negative. And this negative comes from this negative sign. Sine of negative pi by 3 is negative sine pi by 3. That's the negative sign there. So the lower limit now is minus 1/3, 0. That positive becomes negative. 210 sine pi by 3 over pi by 6. Now you can evaluate this value of this. We can use your calculator. And that will be 1/3, 14,475 plus 105. That 105 comes from 210 times 1/2 divided by pi by 6. Divided by pi by 6 is 6 goes up. Minus 1/3 times 210 times sine of pi by 3. What's the value of sine pi by 3? Sine 60 is root 3 over 2 divided by pi. And that's simple to evaluate. That will be 4,940.8 with this one, plus these two minuses become positive, 66.8, and that is approximately 5,008 cars. That is the average sales of these Japanese cars from January to March, the first 3 months of the year. All right?